We dealt with skewness earlier. Okay, so we saw how to calculate skewness using Excel. Now let's talk about kurtosis. Kurtosis is a statistical measure used to describe the characteristics of a data set. When normally distributed data is plotted on a graph, it generally takes the form of an upside-down bell. This is called the bell curve. The plotted data that are farthest from the mean of the data usually form the tail on each side of the curve. Kurtosis indicates how much data resides in the tail. So actually, if you read some old statistics books, they actually tell you that kurtosis is the steepness or flatness, okay, of the top of the curve. So when it is steep, that's high kurtosis. When it is depressed, that's low kurtosis. Well, that may be true, but what really forms the kurtosis is not really the tip or whatever. What indicates what is most important in kurtosis is the nature of the tail. When the tail tend to contain less data, okay, then kurtosis will be low. When the data contain more data, kurtosis will be high. Okay. Distributions with like kurtosis have more tail data than normally distributed data. Okay. So the tail is like not long, short, but thick. So more data goes to the tail. Okay. So with more data, the tail data is what matters. What happens that way? Distributions with a large kurtosis have more tail data than normally distributed data, which appear to bring the tails in toward the mean. So that makes the tail to be closer to the mean, like this green one you are seeing now. Okay? You see the tail is closer to the mean, closer to the center, thereby gathering more data compared to this slim tail. Okay? So, and that is what pushes the top up and makes it steep like this. Are you following me? Is it clear? Thereby making it taller than normal distribution. But in the case of low kurtosis, where there's less data on the tail, that makes the top to be depressed. Okay? That's low kurtosis. Well, all these analyses are not really, you may not be using all this on day-to-day basis, just for knowledge sake. Distributions with low kurtosis have fewer tail data, which appears to push the tail of the bell away from the mean. Push the tail away from the mean. Okay? So generally, high kurtosis, data with high kurtosis are usually steep like this. Data with low kurtosis tend to be depressed like this. Okay? Does it make sense? Is it clear? Is this clear to us?
Yes, sir. Yes, sir.
1 minute.
Yes, sir.
All right, so kurtosis types. Leptokurtic, that's high kurtosis, where kurtosis is greater than 3. The distribution with positive SS kurtosis is said to be leptokurtic or leptokurtotic. Lepto means slender. In terms of shape, leptokurtic distribution has fatter tail, but is steeper at the center, at the top. Mesocortic kurtosis of 3. This distribution has 0 excess kurtosis and are called mesocortic or mesocortotic. The most prominent example is the normal distribution family. So normal distribution is mesocortic, which means it doesn't have excessive steepness or depression, regardless of the value of its parameters. Platycortic has kurtosis less than 3. A distribution with a negative SS kurtosis is called platycortic or platycortotic. Platy means broad. In terms of shape, a platycortic distribution has thinner tails. Now, you don't need to memorize all this, okay? It's just for knowledge sake. All right, so let's get down to practical. To compute kurtosis in Excel, you use the curt function. The curt function, C-U-R-T function. So let's see how that works. Again, we are going to use the same data. Let's use the same data, kurtosis. Close cuts. So, what do you think of this? Low kurtosis or high kurtosis?
Is low kurtosis.
Low kurtosis, yes. Can see it's negative anyway, so kurtosis is low. Let's see. Let's try to bring
High kurtosis.
high kurtosis. Why do you think it's high? You think it's high?
I'm just seeing it now.
Okay, you have okay. You didn't see this. Didn't see this figure before.
It's minus sign.
Okay, so is it high or low? Do you think it's high or low?
And you said something in your explanation. You said when the taste is low, it will be high kurtosis.
Okay. So in this case now, what do you think?
That's what I thought. To be high.
Okay, thought to be high.
It's high kurtosis.
Okay, you say it's high kurtosis. Why do you say so? Why do you think it's high? Why do you
Yes,
think?
sir.
What makes you think it's high? Did you hear me? Why do you say it's high? Hello, Sadre, can you hear me?
According to your explanation, I'm trying to uh, play my mind on it.
Okay.
Yeah, can I hear you now?
Yeah. So I didn't really get what you said. You said you think it's high kurtosis. You saw the figure. You know it's negative figure, right? Like you have network issues from your end.
Yes.
So how could that possibly be high kurtosis? I don't know if there's, what I'm asking. I don't know, is there something I said that is creating that impression? Is there something I said that is creating the impression?
Yeah. So I was thinking from the point you said, when the T is low, you have high kurtosis. And when the T is high, you have low kurtosis. So I was thinking from that
Okay.
point.
Okay, in this case now, you cannot, mainly by looking at these figures, you cannot,
So that's why I said it's high.
you, no, mainly by looking at this figure, you can't tell,
But you can put it on.
hello, mainly by looking at this figure, you can't tell the nature of the tail now. You can't tell. Do you understand me? There's no way you can tell what the tail would look like looking at these figures. Can you tell? Just by looking at the figure. You can't tell what the tail will look like. So after your calculation, what you need to do, just look at the figure you got as your answer. Then you determine, you make your determination based on that figure. If you have a negative number, of course, that's a low number. You understand? So
Okay, sir.
that's the idea. Trying to see, and it's not very easy to tell, to really. Okay. You see, when the skewness, for example, is very low, you may not see obviously from the shape, but the calculation has been done, and Excel is telling us that the data is right skewed. It's telling us that the tail is on the right. Okay, but if you look at this, because the scattered nature, you may not be able to tell. Okay, because it takes so many things into consideration, all these depressions and the rest. Okay, because it is not smooth, it's not smooth and regular. So it visually is difficult to tell what the skewness will be like. But if it is smooth and regularly distributed, then it is easy to inspect, do visual inspection, and just see what the skewness is like. Okay, same with kurtosis. Same with kurtosis. But for the kurtosis, I'm sure the kurtosis, I don't think that will be a high figure. Equals let me get that range. Now you see this kurtosis is low. If you look at this data, we are not surprised, right? It looks kind of flat. Are we there?
Yes, sir.
Yes, sir. Yes, sir. We're here.
Yeah.
But can't we use a curve to be sure?
Yes,
Because this
sir.
one is.
Yes, sir.
Then can't we
Can't
use
we use curve like the other one?
even if you use curve, you really one thing you should know about this data is that in many cases you don't find data that is smoothly distributed like that. Okay, that's why you need aids like Excel, or, the computer to help you do your calculations, or you do the calculation manually if you are doing a manual statistics. Okay, but let's see what the curve will give us. Normally, this kind of thing, you use a histogram to handle this type of thing. Normally. You see it? See, it's still jagged. Let's see area charts. Because it's not smooth. It's not, in real life, sometimes data don't occur smoothly as that. Okay. Sometimes it does, sometimes it doesn't. And of course, this is not real life data anyway. Okay.
Okay, sir.
It's not real life data. So I hope the explanation is clear. So what you do is you just do the calculation. The figure you get will give you an idea of what we are talking about. Okay. Here you can see the skewness is positively skewed, which means technically the tail, if there's a tail, the longer tail will be on the right. Okay. And then the kurtosis is negative, which means this data is not steep. It's not steep. It's kind of depressed. Okay. So that is that. Okay, so now we have looked at our skewness and kurtosis. We've looked at normal distribution. So let's look at one more topic today. Did we do ranking yesterday? Yes. We did ranking yesterday, right?
Yes.
Yes, yes. Okay, now let's look at, yes, this referencing. Do we need a review on that?
Yes, sir.
Yes. How many types of referencing do we have? Okay, can somebody that remembers give us a review on referencing? Can somebody explain to us the different types of cell referencing, also called cell addressing, and how to use them? Anybody want to help us? Is there a good Samaritan that wants to do that for us in the house? So does it mean we don't
I
have?
didn't get the question, sir.
Okay, so you might be the good Samaritan then. I said, is there anyone who remembers cell addressing methods or cell referencing methods? Anyone remembers that? If you do,
Uh, uh,
just
I think we have,
explain it to us. Yes.
I think
Okay.
we have a relative reference,
Relative
absolute,
referencing.
yes, absolute and mixed reference.
Okay. We have relative referencing. We have absolutes. Then we have mixed. There's one left.
We have absolute and relative, absolute and mixed. That's the theory I know.
Okay. Apart from that, there's another one called 3D referencing.
Yeah, 3D, yes.
You remember now. 3D.
I think we didn't do 3D, but we just did 2D reference.
Oh, sorry. I mean 2D. Thank you for that.
Yes.
I mean no. It's 3D. It's 3D, not 2D. Okay, when you say 2D referencing, what are you talking about?
I know we talked about 2D. I don't know if it was related to referencing or something. We talked about 1D and 2D. So we didn't talk about 3D because you said the essay is in 2D shape, the
Exactly.
horizontal and vertical. So
Exactly.
there's nothing like 3D.
That's correct. So Excel is 2D. That's correct. That's why I said naturally everything you do in Excel basically 2D. So all these are actually used in 2D mode. 3D is when you are addressing across worksheets. Okay, that's what 3D is about. When you are addressing, making reference to cells across worksheets. Okay, now look at this. Let's say you have there's need to give bonus to staff for 20,000, all the staff. Okay. Now,
I can't see your screen though. I'm still seeing the practical demo.
oh, okay. You are still seeing the practical demo.
Yeah.
Are you seeing my Excel screen now?
Yes, you can see it now.
Okay. So I said, let's say, for instance, let's just quickly demo this referencing thing because it's very, very important. You should be used to things like this. It helps you a lot in Excel. Okay, now, We are used to relative referencing. This is what we use all the time. Okay? We use relative referencing all the time. We use it all the time. For example, if here now we have, let's say we have basic salaries, basic. Let's just make it brief. Let's say we have allowances. We have gross. We have tax. And then we have net. Okay. Let's just leave these figures here to make it faster. So let's say we want to get gross now. What do you think gross would be? Gross is equals basic plus allowance. Very straightforward. This is relative. The default is relative referencing. Okay. You see, it just says A3 plus B3. That's the default. That's relative. Why is it called relative? Because you see, I copied this formula just now. See the formula that was written here. A3, B3. Okay. But when I copy it down, if you come here, it has updated it to A4, B4 on its own. A5, B5. A6, B6 on its own. That's what happens when you use relative referencing. Okay. So the same thing with tax equals, let's say gross, okay, gross times, let's say times, let's assume the tax is a flat rate, which usually not, 15%, 0.15.
0.15.
Or is it supposed to be B3? I think B3 is
Supposed to be this one times 0.15. Net, all these are still relative, isn't it?
Yes.
Minus tax, still relative. Can format this to be okay. So now let's say you want to give every staff bonus of 20, irrespective of your grade level. Okay, everybody needs to want to give everybody this. Okay. Net net plus bonus. Okay. So now, suppose I now say equals, you tell me what to do. Plus
Plus bonus.
This is bonus. Is that correct?
Yes.
Do you think this one is correct?
No, that one is not correct. Only the first one is correct.
Only the first one.
Yes.
This is where you need absolute referencing. Why is only the first one correct? Because if I double click now, you see it's picked it. This one attempted to go down to pick the next figure because it's relative referencing. This one went down. Are you getting it? So to stop that from happening, you have to use absolute referencing. Okay, can just highlight that and press F4. So it will put $sign there. So that way to be correct. Why? Because it keeps picking that 20,000. The $sign makes it to be fixed, makes it not to move. This is absolute referencing. It's absolute referencing. Okay, but actually here we don't need to use $sign on both the rows and the columns. Why? Because we are dragging across rows. We want it to be fixed across the rows, not necessarily across the columns. So even if we remove this $sign, it still works. Okay, we remove this first $sign. This is mixed addressing because the H is relative, but the 3 is absolute. It will still give you the correct answer.
Mixed referencing.
Mixed referencing, yes. Referencing is also called addressing. Okay. So mixed referencing is when you put $sign in one out of the rows and columns, and you don't put $sign in the other one. When you put $sign in both, that's absolute. Okay. Are we together?
Yes, sir. Yes, sir.
Then 3D referencing is when you from one cell attempt to reference another cell. Sorry, from one sheet. Okay. I'm trying to get something from another sheet entirely. That would be 3D referencing. Okay. That would be 3D referencing. For example, let's say, for instance, now, from here, I can access what's here. Can access it. Okay. Let's say I want to access this figure now, this skewness. I can get it. I can say skewness. Or I am here. I want to use this data to I want to compute the skewness, but I want it to be on another sheet. I can say equals. I just click